All right, I should be recording now. It's not, I don't see the indicator that I'm recording.
It says you are recording on my
Oh,
screen.
am I? Okay, great, thank you. I don't know, YouTube has changed, I guess. Okay, so start again. I'm Marco Callahan, PhD, or Dr. Marco Callahan. This is College Physics 1. Again, as I said, I'm not pretentious. You can call me whatever is comfortable. Mark, Dr. Mark, Professor Mark, whatever. Again, I want this to be a cordial environment, and I treat my students as if they're coworkers. This professor-student relationship for me is flat. I know you're taking a class in the evening. I know a lot of you have a lot of other things going on in your life. And so I respect each and every one of you coming to my class. And as I've said, I treat more people more like coworkers than the typical professor-student relationship. Anyway, we will start meeting normally starting up next Monday. And so what I want to talk about tonight, and even if I was actually face to face today, we wouldn't really be getting very much done in physics. What you have to do starting off is kind of talk about what the class is about, what you expect from me, what I expect from you, talking about the syllabus, talking about, what is physics. A lot of that is, and so tonight was really more of an administrative session. And with Memorial Day being Monday, the lectures are Mondays and Wednesdays. So we would actually have a very weird week to begin with. We'd have just one lecture and 2 labs. And so the whole week is a little bit, kind of off on a not so good foot to begin with. So anyway, so as far as this class goes, the basics are, what I want to talk about tonight is what is physics? Why are we all here? What is the point? Why, what's the purpose of this class? And some of you have to take physics 1 and physics 2. So what is the point of the class? And then on top of that, I'll tell you a little bit about myself, and then a lot of this is going to be, we're going to going through the syllabus and making sure that we all understand, what is expected and required in the class. Syllabus is kind of the law of the land, if you will, of the class. All right. And so first and foremost, let's talk about what is physics. All right. So physics is the queen of the sciences. It is the base science. And so oftentimes I tell people there's a little diagram I like to draw that kind of relates physics to the other sciences. And so if you're taking physics 1, and I'll talk about the differences between university physics and college physics in a second, but physics in general, you look at the universe. The universe is based on the language of mathematics. All right. So the common language of the universe is mathematics. And no matter what language you may speak in the vernacular, whether it's English or Spanish or French or whatever, everybody has the same mathematics. So, for instance, when I'll tell a little bit more about myself. I have 5 college degrees. One of them is a bachelor's in mechanical engineering. So I went to Washington University in St. Louis and for my mechanical engineering bachelor's, and I had about 8 suite mates or 7 suite mates. We were like 8 guys living in a big giant apartment, if you will. And one of my friends, I'm still friends with him today. He's a German guy. And so he came over to the United States, and he only spoke German, and he kind of learned English along the way. And a lot of his English he learned was, through being a physics major, and so he would understand what the word was in German, and then he would say, "Oh, that's how they say energy. Oh, that's energy in English. Okay, that's interesting." So he would kind of translate along the way. And I went to go ask him a question one time, and one of the most important books you can have in physics is called the CRC mathematical table and formulae. And CRC stands for Chemical Rubber Company, for whatever reason. But it is a book that contains all of the mathematics that you could ever really study. Particularly if you're a physics major. So it contains all the integrals from calculus. and trigonometric identities and formulas from geometry and you name it. I mean, it's going to be all looked up in one book. So that's really a must have for anybody. So he had that book open on his desk when I went to go and ask him a question. And I understood all the mathematics. He was looking up some integral, from integral calculus. And I understood all the mathematics. Then my eye kind of trained a little bit lower into the text. And I didn't understand any of the text because the text is written in German. And I don't speak or read German. And I thought, that's very interesting. I have the exact same book in my room, but mine's in English. And yet the mathematics is the same. I can completely understand all the mathematics in his book. And so the mathematics is literally the language of the universe. Now, physics interfaces with the universe, and that is the main, and it does so through what are called laws of physics. I'll talk about that in a moment. That's the interface. So laws of physics are the interface. So physics, we understand, we connect with the universe through laws of physics. These are behaviors of the universe that are always true, that do not have a more fundamental cause. I'll write that in a moment. But we have to find them. We don't actually have a reason for them to even be. We find them, we discover them, and so they are. And they are the basis of all of physics. Now, some of you guys live up here. So chemistry derives from physics. And so to do chemistry, I mean, really, chemistry is applied physics in many ways. Quantum mechanics, chemistry is quantum mechanics. So, the physics of the valence electrons, the upper electrons in the atom. The physics there, the quantum mechanics is what is chemistry. That is the chemical interactions that you study and you do in stoichiometry in your chemistry class. Well, that is applied quantum mechanics. That's the behavior of the electrons, and particularly the outer electrons. And then a lot of you guys might live up here. So deriving off of chemistry is biology and maybe geology. All right. And so now we have hybrid sciences. There's for instance, there's chemical physics, there's biochemistry and things like that. And so there are other branches, but it's a very basic diagram that more or less states, where you guys reside. So a lot of you guys reside up around in here. And so the whole point is, why, I don't really see physics all the time in my biology class. Well, the thing is, because you're being shielded by chemistry, and then chemistry, it depends on physics. And so a lot of times people say, to be a great biologist, you have to be a good chemist. To be a great chemist, you have to be a good physicist. To be a great physicist, you have to be a good mathematician. And then, to be a great mathematician, you just have to be smart. That's the joke I've heard from a lot of physicists. In this diagram, I had the fortune of having my very first ever Physics 1 class taught by the chair of the department at the University of Puget Sound. And so he drew this very diagram, and so I oftentimes repeat it. Okay, so this is how everything is related. So in your major, whatever your major happens to be, there are people who are the governors of your major. They're the people who make the decision on what goes into your curriculum. And all of this, and that particular body of people have all stated that you have to have at least College Physics 1. Now, let me talk a little bit about the difference of college physics versus university physics. So some people will accidentally get in the wrong class. So I want to make sure that, you're in the right class. Right. And so university physics, which you're not in right now, relies on the real mathematics. It relies on calculus. All right, you're not in that class, but that's the difference. So we study the same stuff. College physics does not. College physics relies on algebra and trigonometry. or you can call it, say, pre-calculus. All right. So why do some people have to take college physics and other people university physics? Well, it's because of your major. All right. So for university physics, the general rule is, what you have to, are you in the right class or not? Well, in university physics, typically the people who need to take that class, I mean, if you are any form of engineering, so that'd be mechanical engineering, electrical engineering, computer engineering, chemical engineering, civil engineering, any kind of engineering major, you don't belong in this class, you belong in university physics. Another form would be computer science, physics, of course. If you're any of those majors, then you need to be in university physics. Now, for college physics, basically, it's any sort of bioscience. And I think chemistry as well. So the bioscience, that would include pre-med, pre-dental, pre-veterinarian, pre-optical, optometry, biology, of course, pharmaceuticals, any of that, you belong in college physics. Now, again, depending, you might, some particular majors say you have to take college physics 1 and college physics 2. And some say you just have to take college physics 1. Pharmaceuticals, for instance, I see a lot of people just have to take college physics 1 for that. How do you really know for sure? Well, TCC is a pass-through school. So people really go to TCC to go somewhere else eventually. A lot of times people, you should have somebody at the other school who is a point of contact for you. Those would be people who would answer those questions. Everybody has an advisor as well. So you should know who your advisor is. Those are people who also are people who can answer those kind of questions. So make sure you know what it is you're supposed to take. Most people get it right, but every so often, I get somebody, usually about one student per semester says, "Oh, I should have been in university physics. Sorry, professor." And I just want to belabor this now because that way you're not you're not in the wrong class, or you don't find out about it until you're like midway through the semester. This term, I guess the term's only 10 weeks. Any questions about that from anybody? Okay. So, pointing that out. So again, physics, let me talk a little bit about, I talked about laws of physics. All right. And so a law of physics is a behavior of the universe that is always true but does not have a more fundamental cause. It is a primary. All right. So there altogether is about, say, 25, a couple dozen laws of physics. You have to find them. And and if you're asked a bunch of why questions, why is this? Well, it's because of that. And why is that? It's because of that. So on and so forth. You get a string of why questions. At some point, every string of why questions ends up at a law of physics. And if you were to ask, why is this law of physics? The answer is nobody knows. If I were to ask, why is Newton's second law? Nobody knows. I mean, it just is. We had to find it. And it's one of those things that let's see, I don't think I have, here we go. It's one of those things that, it's a little bit unsettling that we don't know things better than that, but again, that's the way it is. We know we're, this, our, we rely on physical laws. Okay, now, in this particular course, we're going to cover what is called, now we're going to cover two different theories. All right, so let me talk about what a theory is. Now, one of the things you'll find out in science is that there are a lot of words in the vernacular that are misused or abused. They're not used correctly. One of those words is the word theory. A lot of people think they know how to use the word theory correctly, but the reality is, they really don't know, and they're not using it correctly. So let's find out. What does a theory mean? A theory is a mathematical framework that precisely predicts or precisely predicts the behavior of a class of physical phenomena and it relies on a set of laws of physics. All right. So you have a theory. It's basically a body of, basically a mathematical framework. I mean, it's based upon mathematics, and it's based on a set of laws of physics. Usually, it's about 3 to 4 to 5 laws, about 3 to 5 laws of physics, and it predicts it very precisely. They're very successful. They predict the class of physical phenomena, and they fundamentally rely on a set of laws. Okay, that's the concept of what's called a theory. Now, a theory it is again, a mathematical framework. It must be predictive. It must be based on laws of physics. Other kinds of things that people call theories are not theories. All right. A theory is a word that literally sprouted from science. Now, in our class this semester, this term, the summer term, we're going to go through two major theories. All right, I'm going to kind of lay them out so we know what's coming at us. We have the theory of mechanics. All right, so mechanics is a theory. Oh, didn't say Siri, sorry. Mechanics is a theory that governs the behavior of bodies or systems in motion. In all three modes of motion, which is translation, and I'll talk all about this term, rotation, and oscillation. And in all three major states of matter. And that is solid, liquid, gas. Now that's a tall order. That is a lot, to put into a single theory. Translation is a body moves as if it's a point particle. Every single body in part moves in translation. Now, if a body has more of a geometrical definition and it rotates about an axis, it's said to rotate, like a baseball rotates. And then there's some bodies that will undulate. Basically, they're not rigid any longer. They have some flexure and some flexibility, and oftentimes they undulate in a sinusoidal manner, like a sine wave or like a sine function. That's called an oscillation. A more common word we use is vibration. So translation. So again, mechanics is chapters 2 through 11 in our book. I'll talk about our book in a moment. So translation is going to be everything up through chapter 8. Rotation is translation is everything up through chapter 7. Rotation is chapters 8 and 9. Oscillation is chapter 10. All right. So again, 2 through 7. Rotation is 8 and 9. Oscillation, again, we'll see this semester, is chapter 10. And then solids is everything up through chapter 11. So chapter 11, liquids and gases are together called fluids, and that's the subject for chapter 11. And that is the last chapter. Chapter 11 is fluid mechanics. Again, we'll talk about all this face to face. Now, mechanics is a theory, and it's based on just 4 laws. All right, so a whole bunch of behavior, all the different categories that constitute a mechanical system, and yet everything is only based on 4 laws. All right, so mechanics is based on just 4 laws. And we'll talk about these. And I'm just giving you a preview. We have Newton's first law of motion. We have Newton's second law of motion. Newton's third law of motion. And something called the conservation of energy. I claim that most people do not know what the word energy means. We use the word energy all the time, but if you think about it for a moment, what really is energy? Now, we use it. We have a department of energy. We have an energy drinks, energy bars, you name it. But what really is energy? We use the term all the time. And so I will tell you what energy is in this class. Newton's laws of motion, that's the subject of chapter 4. And conservation of energy is the subject of chapter 6. Again, all that's going to be covered here. Isaac Newton lived between 1642 and 1727. He was one of the most amazing, most brilliant human beings who ever lived. And the entire human race did not know of laws of physics until Newton lived. And so Newton was the first human being who understood laws of physics. Most of this class can be attributed to the work of Isaac Newton. All right. Chapters 2 and 3, we'll start chapter 2 next week. Chapters 2 and 3 will be what's called kinematics. That's the work done by Galileo Galilei. He preceded Newton. In fact, he died in 1642. Isaac Newton was born in 1642. So Isaac Newton was born Christmas Day, 1642. So funny, one of the greatest scientists who ever lived died the very year that another scientist, one of the greatest scientists who ever lived, maybe the greatest scientist, was born. And so again, the human race, did not know about laws of physics. And of course, what made things so amazing with Newton is that, people were, other scientists looked at that and said, well, might there be laws of physics that govern other phenomena like electricity, magnetism, light, thermal physics, things like that? And the answer is yes. And so again, mechanics, chapters 2 through 11 will be based on just 4 laws of physics, period. Now, moving on from, from chapters, after chapter 11, we have another theory, the second of the 2 theories in this class. And that will be called the theory of thermal physics. So thermal physics is a theory, or the theory, that governs systems which exchange energy with the environment. In the forms of work and heat. Okay. Also included is the kinetic theory of gases. And I'll talk about that in a second here. Now, we did not know of the existence of atoms until 1827. Now, that may seem like a long time ago to you, but that's not that long ago. And so when Newton did not know about atoms, it was actually hotly contested whether atoms actually existed or not. Strange as that may sound, the great Richard Feynman, is probably the greatest physicist since Albert Einstein. He was asked one time if there was a great cataclysm and all of the knowledge of science were to be destroyed except one thing, what would that concept be? And his reply is, all things are made of atoms. For him, he says, if I can understand that, then I can derive everything else. Now, of course, that's Feynman. Feynman can say that, but most other people could not do that. And here's the most important thing is all things are made of atoms, and yet that's a very young piece of knowledge, right? And so really, thermodynamics was the original thermal physics, and it is a theory purely involving energy. It wasn't until 1827 where it made sense to actually have a theory that talks about atoms and molecules. So the kinetic theory of gases is the very first ever theory of humankind that is a theory that's an atomic or molecular theory. It's a theory where we can consider systems of gases as particles, as systems of particles. Before that, we could not do that because we did not know about atoms. We did not know what the submicroscopic was or what it consisted of. Again, young piece of information. All right. So thermal physics is chapters 12 through 15. Okay. And then we have 2 more chapters in this class, and that's going to be on what's called waves. All right. And so waves are interesting in that you look and say, well, you'd say there's 2 theories. Where do waves belong? Again, that's going to be chapters 16 and 17. And that's it for this class. Waves. So waves, in the most pedestrian definition, waves are just, well, yeah, let's make it singular. A wave is a disturbance that propagates. Propagate is a fancy word for move. All right. So waves of disturbance that propagate. So if I imagine that I tie a tight string, a very taut string between two posts, and then I say, well, that string is then I disturb it. I basically start, have an oscillator, start moving it up and down. What's going to happen now is I will create a disturbance that's basically in the what we call the y direction, the vertical direction. And this is where the string would have been before, but now I essentially have a disturbance that propagates. That disturbance, an up and down motion, moves with a certain wave, with a certain velocity down, from one post to the other. So even though my disturbance is in the y direction, that disturbance, that ripple, propagates along the direction of the wave. So maybe we can call this the x direction, that the y direction. We'll get into all the mathematics. So the question is, where do waves belong? Waves belong to all theories. So mechanical waves in this semester. That could be waves on a string like a guitar or violin. That can be acoustical waves like my voice, you hearing my voice. That's essentially disturbing air around you, and those waves are vibrating your eardrums right now. I mean, that's a wave as well. And certain water waves are also mechanical waves. But if you take physics 2, you will study what are called electromagnetic waves. And in fact, in physics 2, you will study what's called quantum mechanics. So that's my area. My area of research is quantum mechanics. Quantum mechanics basically states, this is going to sound like gobbledygook to you probably right now. Quantum mechanics states that everything in the universe, every entity in the universe is both a wave and a particle simultaneously. All right, so that's very deep. Quantum mechanics, and this is a peek into physics 2, is the physics of the submicroscopic, the very, very small. It says that all entities in the universe are simultaneously a wave and a particle. Now, it may seem strange, but again, it'll make more sense in physics 2. So waves are actually very, very deep in meaning. They are actually a fundamental statement of existence. All right. And so if you think about this for a moment, you have light. Let's say light. All right. So there's a big fight among physicists back in the across the centuries. What is light? Well, light, most people thought it was most people thought it was a stream of particles. They call it corpuscles. That's because that's what Isaac Newton believed. Very few physicists were wave adherents. They believed in the waves. And so you hear people like Christian Huygens and Thomas Young, and eventually James Clerk Maxwell, who developed electromagnetic theory. For the longest time, it was by about 1865, around the time of the end of our Civil War, In Scotland, Maxwell came up with the theory of electromagnetic theory. So they weren't fighting in Scotland, only we were fighting at that point in time. And yea, verily, light was considered a wave. But then when the development of quantum mechanics happened, a guy by the name of Albert Einstein had to describe what was called a photoelectric effect, which is basically light ejecting electrons, like you might see in the solar cells of your calculator, or some of the solar cells on road signs, or also, I mean, my gate operates through solar cells. Well, that's basically light that has to be considered a particle that collides with atoms, ejects electrons, and creates a current. So light is both a wave and a particle. And we call the particles of light photons. So depending on the experiment, no experiment that will show light as a particle will ever show it as a wave. And no experiment that shows light as a wave will ever show it as a particle. There's what's called a particle wave duality. Okay, so again, this is kind of going way ahead. I'm just kind of giving you an idea what physics is about. You might ask yourself the question, well, what about another small thing that we think of as a particle, as an electron? Well, there's the electron particle and an electron wave. Electron waves do exist. And so the wave equation for the electron, that's the solution of what's called the Schrodinger equation. All right, so again, that gets into quantum mechanics, so forth. That gets into physics too. But I just want to let you know that, waves, there's much more to waves than what we're going to study in this class. All right, and that covers what we're going to talk about in the class. I mean, generally speaking, we're going to talk about two major theories, mechanics and thermal physics, and we're also going to talk about waves. All right, and yes, we will meet face to face. So any questions right now? Again, that's a kind of a fire hose overview.
Teacher,
Yes.
yeah, by the thing you said before, I just double check on my like my school, the like where I plan to go
Yeah.
after TCC.
Yes.
And I think the class I should take is physics 24, 25.
What is your major?
Like data science. I planning to transfer to data science.
You're probably right. But I would check that though. Just be careful. You're already in this class, and semester starts tonight, so you'd have to act quickly.
Yeah.
But I mean, I wouldn't make any moves quite yet. But so again, I mean, but yeah, it's good you're looking that up, and it's a very common thing. I mean, don't feel bad that. I mean, it's one of those things it's hard for you to know, coming out as having not had physics before, to know, there's this difference between university physics and college physics. I mean, it's hard to know that. It's what the advisors are for. So yeah, you might be right. Data science, you're probably right. That goes more into computer science.
But it's too late right now to drop the class, so.
Well, stick around with me, I guess. I had a guy one time. He liked my class quite a bit, and he and realized about midway through the semester, I'm a mechanical engineering major, and my desire is to go to UTA. But I like your class enough. I actually want to take your physics 1, college physics 1, and college physics 2, and then I have a strong enough foundation. I'll go to UTA and take the university physics classes. So that's what he did,
Okay.
and that really prepared him well, because then he could say, okay, well, I got all the concepts down, and now I have to look more into the mathematics. But you literally will cover the same concepts.
Yeah,
And in
thank you.
fact, there are some schools have a conversion class as well. For instance, you might say, hey, I took college physics. What do I need to do? Is there some little interim conversion thing I need to do
Mhm.
to have things acceptable by you? So you might want to check into that too.
Yeah, thank you.
Yeah, don't do anything yet until because once you drop, you can't get back in. So
Yeah, thanks.
yeah, no problem. Any other questions? All right, so now we get to the part of the class. It's not as exciting. So I'm going to talk a lot about now. Some of you guys have maybe never been to TCC before, and some you may have taken classes here again. So this is a face-to-face class. As I said, it's being started in a very unusual manner because this my schedule in this class kind of had a little conflict in the beginning here. So I apologize for any inconvenience to you. I'm doing my best to make up the difference here. All right. So what I want to do is kind of go through some fundamental things about more or less how does the class operate, and so one of the foremost things you need to be able to do is make sure you can log into your TCC account. To make sure you have a TCC account, you can log into it, you can access it. Now, this everything at the school is done in what is called Canvas. Now, Canvas, strangely enough, I'm going to share my screen here. So give me a moment. Here we go. All right. I'm going to share and show you this. Okay. What you should see right now, I hope, is a Canvas screen. Does everybody see that? Shouldn't really see
Yes.
me anymore. Awesome. Thank you. Okay. So when you log into Canvas, your view is going to look different than mine. I have the professor view, but you'll have various classes you're taking right now, and this is the class year 2024 summer physics 1401 29001. And so you go into this, and again you'll see some basic page that's a home page for me, and so you see a little bit about myself. You see about the class. You see this little equations page. Now, give me a number of again, some of you, if you're here, you probably understand how to find the announcements. I use the announcements quite a bit. And so I'm going to talk about the syllabus for a bit tonight. So the announcements is going to be you go there, and I again I mentioned I made some Zoom links, the one for tonight. So you clearly have seen how to do that. So good. I had a couple students that didn't seem like they were getting on Canvas. I wrote them personal emails to hopefully they can get on. So I'm not sure. So again, it's a little bit rough in the beginning. A lot of us are trained in the pandemic, era. So we kind of know how to use Zoom now. Most people, not everybody. Um, I'm going to do student view here so you can kind of see things as I see things. All right. Let's see here. Your grades, you'll be able to see, how your grades are. I'll talk about grades in a second here. As far as assignments are concerned, you go down there and you'll see right now there is nothing. So again, as I go through and assign things, and I'll talk about how I'm going to assign things, how often, how frequently, you'll see those assignments populate this page. Right now, there's nothing because we're just getting started. But one of the most important categories here is files. So a lot of things are going to be done in the files. And so first of all, let me talk about, we're going to have labs in the class. And so there is no need for you to buy a lab manual. All the labs are here. Now I'm going to mention here that we're going to have group labs. So we go to class, there are about 20 of you right now. So you'll divide nicely into about 5 groups. I like to have groups of 4. So when you go to your group lab, you'll get into groups of 4 and you will work together in the lab. You will work together doing the calculations, and you will have to print out just one lab for your class. And so the first lab is going to be printed out for you, because you don't even have a lab group yet. And so when we meet for the first time, and it'll be Monday, we'll meet for the first time on a lecture night. So the first lab we'll have together is on Tuesday. And so all the labs are labeled, hopefully in an intelligent manner. The first lab we'll cover. So again, one of the files looks different than all the other ones. It's the one that looks like a spreadsheet. So let me open that one up right now. That's very important. That's going to tell you what we're going to do in the lab. Okay, so the way the class is set up is we meet on Mondays and Wednesdays for lecture only. We'll meet in NSCW 1244. That's downstairs in the NSCW building. On Tuesdays and Thursdays, we'll meet in NSCE 1118. On Tuesdays and Thursdays, all we will do is either take a lab or an exam. All the exams in this class will be during a lab time. So you will go to, so I notice that we're blank for today. And I'll talk about this data analysis home assignment in a little bit. The first lab we're going to do as a group is called the measurements lab. That's a very easy lab. We'll do that as a group. So we'll get together and do that lab next Tuesday. Now you'll notice that, okay, well, let's see. That's Tuesday, June 4th, Thursday, June 6th. We have this thing called uniform accelerated motion. Okay, great. Then we go back to Tuesday. We have vectors. Thursday, Atwood's machine. And we know exactly what we're doing. Oh, look at this. On Tuesday, June 18th, we have a lecture exam 1. So that particular day, you're not going to go to a lab. You'll instead go to, you'll go and take an exam. Most likely, I haven't seen like what the competition is for the room, but most likely I will get a classroom, maybe the very classroom where we study, and I will get a classroom that day for the exams. I'm not going to have you take the exams in the lab. That's just very uncomfortable. So either we'll take the exam in our normal classroom or a classroom in case our normal classroom is being occupied by somebody else. All right. So again, this tells you what's happening on Tuesdays and Thursdays. Okay, Tuesdays and Thursdays, this is what's happening. Either there is a lab or an exam. There are a grand total of 11 labs. First one I have here is a take-home assignment, and I'll talk more about that in a little bit. All the other labs in the take-home assignment, listen carefully. The take-home assignment is individual. So there's 20 of you. I expect 20 individual data analysis labs. Now, for all the other labs, we'll be meeting face-to-face and doing physical labs. I only expect about 5 labs, 1 from each group for all the other ones. So again, I expect for a data analysis lab, I expect 20 individual lab assignments that you will turn into me physically, a physical copy. From all the other labs in the semester will be, again, physical copy. There will only be 1 copy per lab group. Again, so we'll say more about that, when we meet, or we'll talk more about the data analysis lab in a bit. So any questions about that? So then, very important, this will tell you exactly what's happening, what is happening on Tuesdays and Thursdays. Any questions about that? All right. Now, for all the other labs, if you say, oh, measurements lab, that's the one next Tuesday. Let's see here. What would that be? Well, it would be called, I think I have it in here.
Excuse me, sir, for the lab, what is the time?
The lab, everything is going to start at 8:30. So again, Mondays and Wednesdays, it's lecture.
Mhm.
Tuesdays and Thursdays, it's lab.
Okay.
All right, and they're different locations. So we'll talk more about this. Let's see, laboratory measurements. There it is. I was looking for measurements. So if you look, where's the laboratory measurements lab? Well, it's going to be right here. And so again, the first lab will be printed for you. Again, I'll say that again. But if you want to look at that, somebody in your lab group would print out the lab, and it's going to basically tell you, walk you through the lab. So again, we'll talk more about that when we actually meet face to face. The data analysis lab, that's this one here. This is the lab you will print out individually and work out. Now, I'll say more about this lab in a moment. But again, that's the lab. In that data analysis lab, it's basically the purpose of that lab, and I would not put this off the last minute. This lab is not anything that it's the purpose of it is to cover mathematics that you should know for science courses at the college level. This is actually not a physics lab. This is a science lab, particularly a mathematics lab. So it's really the mathematics for labs. And so any course that has a lab where you take data and you analyze that data, the concepts in this lab apply. All right, so that could be not just physics, but that could be chemistry, biology, you name it. If you're taking data, you're writing down numbers, you're analyzing those numbers, this lab applies. So again, I'll say more about this in a moment, but so again, all labs will be due on Thursday. So this lab will be actually due in physical form next Thursday, but I'll say more about it in a bit. And I'm just kind of going over where things are. Okay, so that is a very important folder that essentially is everything there is about what's going on Tuesdays and Thursdays. Again, College Physics Labs, College Physics 1 labs. Homework solutions. No, okay, let me talk. Extra credit. I will give an extra credit assignment in this class. The extra credit will replace your worst lab. It'll be a very simple writing assignment. I'll give it to you in a few weeks. But it'll be the ability to say, well, you're able to really do badly on one lab, and yet I'll generally speaking, what ends up happening is I'll replace you do the extra credit, I'll replace your worst lab with 100 usually. I mean, provided you didn't do your extra credit on ChatGPT or something, right? And so as long as this is actually done in a honest manner, and it's really just a write up, I'll tell you about the details. That is an option. I'll tell you about that in a few weeks. Okay, next one down, homework solutions. When you work on homework, you turn it in and I grade it. I'll grade every single one. I will give you comments. When I handed you, let's say you have chapter 1 homework and you hand it in and I grade it. Well, once you hand it all in, I will put my solutions on here. So you'll start seeing this folder being populated with PDF files that contain my solutions. So you can get your homework back, and if you got something wrong, you can see, compare with my solutions on what you got wrong. And if you still don't understand, then you're perfectly, feel free to come forward and talk to me. But this will start populating. Right now it's empty because we're just getting started. Okay, lesson plan. Okay, that's also very important. The lesson plan really tells you, there's one file in here, and it tells you what's going to happen when. All right. And so we see we have Memorial Day. I'll try to blow this up a little bit. We have Memorial Day, no classes on Monday. This is, so, the other folder had talked about all your Tuesdays and Thursdays. This one talks about all your Mondays and Wednesdays. And so I anticipate talking about chapter 1. Well, basically this week. I mean, the first couple days are, this oddball thing going on. I expect to go through chapter 1 this week. We'll go back to normal next Monday. You can kind of see how I'm going to do things. Kinematics, chapters 2. The class goes quickly. Now notice that something interesting happens. After I get done with mechanics, chapter 11, I'll jump straight to waves. And then when I get done with waves, I'll do a week on waves. And once we get done with that, we'll finish the class up at thermal physics. Why do I do things that way? Because the wave lab comes before the thermal lab. And so we knock out the waves such that you can, I try to do things in a manner where you've already had the theory before you go and do the lab. I don't want to have to repeat myself. There's not very much time for that. So I want to make sure that you've already gone through the theory. And what I'm trying, and the idea of labs is that I don't want you to believe anything that comes out of my mouth. Science is all about proving everything. I will prove to you every single thing I tell you. And so with the lab, the idea of the lab is that we will prove in the lab that what I'm telling you is true. Nature is the ultimate arbiter. Nature is what determines whether something is right or wrong. We can say whatever we want, but doing an experiment and making sure the experiment agrees with the theory is what makes things right. There's a lot of beautiful ideas out there that are just not right. You determine whether something's right or not through nature, through experiments. And so I don't, so the idea of this lab is to say, I'm giving you the theory, I'm giving you the theoretical lecture. Then a little bit later, a week or maybe a few days later, or maybe a week later, we'll do the lab that will test what we talked about in the theory part of the class. All right. So again, I have this thing kind of laid out such that we already talked about the theory before we actually go to the corresponding lab. All right, so this is going to be a very busy class. This first week is fairly easy, particularly with the fact that we're even doing things remote. But the class is going to be very, very busy, and we're going to have a lot to do, and there's not a lot of time. The whole class is done by the end of July. And this is actually one of the slower classes. There's a lot of classes that are 5 weeks, start to finish 5 weeks. I mean, that's pretty crazy. Any questions so far? Okay. Next one down. I'm just giving this to you for free. I was hired by somebody one time she paid me a few $1,000s to work out all of the questions and the 1001 MCAT physics questions. And so I did it for her. And so all of this is essentially, there's a book called 1001 MCAT questions. For those of you interested in taking the MCAT, which is the medical school exam, and the physics portion, I've worked everything out here. So this is all, whoever's interested, is all free to you. I've worked everything out. And so that's just a little freebie. Maybe those who are not pre-med, don't even worry about it. Those who are pre-med, many of my pre-med students have found this to be a useful study aid. Just a little extra for you. All right, OpenStax. So what is that about? Well, in our class, our textbook is called Tucknell and Johnson, 12th edition. I'll talk a little bit more about that. Tucknell and Johnson, 12th edition. Now, when I first started teaching here 8 years ago, the textbook was College Physics OpenStax. All right, so OpenStax was the book. And so I develop all my lectures using OpenStax. OpenStax is actually from Rice University. It's really, quite frankly, a superior book to the book that we use. But what I do is, as I go through doing lectures, what you'll see is that I will have a screen that you'll see that has the problems on it. You'll see the problem that I'm doing. Many of the problems are out of OpenStax, and I will work many, many problems in this class. So not only do I do the derivations and the theory, I will work every single problem. I will work many, many problems in the class, and a lot of the problems are out of OpenStax. Now, again, OpenStax is not your textbook. One of the most basic forms of research you can possibly do is to consult another textbook. This is just a textbook that we'll consult. I don't know if it's ever going to come up or not, but Yeah, I may have just done something bad. All right. Anyway, we're gonna dismiss that. I'll give you the. Hope that doesn't crash my computer. Anyway, I'll show you what the book looks like, but it's a very large file, as you can see, 259 megabytes. But again, it's something that can open up. I don't know why it's not, probably because Zoom is making everything slow. Anyway, that is a reference book. You'll see that reference book. Um, you'll see me referencing problems out of that book many times in the class, but that is not your official textbook. That's again a reference book. Significant figures. This is just something given by the tutoring center. It's just a little help for you talking about sig figs. Again, we'll talk about that. It talks about the rules of sig figs. We'll talk about that in the lab, particularly the measurements lab. So again, just a little extra helper file for you. Another extra helper file for you is unit conversions. Again, in physics, when you're doing scientific measures or calculations, we have to use units. So we'll talk about that. You know, we use so many meters or miles or feet for a distance, or meters per second for a velocity, or newtons or pounds for force, so on and so forth. This is just a helper to convert one set of units to another. So again, those are just helper files. Okay, any questions so far? Okay. I'm going to go out of files now, and that's about it, except for syllabus. So I'm going to talk about the syllabus, and that's not going to be quite as exciting, but it's important to cover everything. So in the syllabus, when you open this up, this is the law of the land, if you will. And so the class starts today, and it's going to be, we meet on Mondays and Wednesdays at 8:30. We meet on in NSCW to 12:44. I'll say more about that in a moment. And we'll meet in the labs at NSCE 1118 on Mondays and Wednesdays. All right. So I will try to arrive. Our class starts around 8:30. I'll try to arrive at 8 o'clock. And so, and you want to ask me any kind of questions beforehand, you can talk to me a little bit, or I'll try to be in the classroom by about 8. Class meets every day now, or Monday through Thursday, I should say. The book for the course, let me stop sharing for a second, and I'll share again. Okay. So let me point out the book for the course is Cutnell and Johnson, College Physics. It's the 12th edition. Again, this is the book for the course. Now, I'll show you the book physically when we get to class, but this is a big book. Again, not the 11th edition, but the 12th edition. All right. So somebody who may have had this class before, well, they'll have the wrong edition because they switched from the 11th to the 12th edition this year. So, as I mentioned earlier, the textbook that we had before that I'm referencing is OpenStax College Physics. Again, that is a reference book. That is not the book for the class, but I will reference it quite a bit. That's the book. Now, what's nice about this book, it's not only superior, it is also free to download a PDF copy. Of course, we can't have that. We got to have people charge students $150 and have them, buy the, Cutnell Johnson book. But I mean, that's, again, I don't make the decision. That's the publishing company and whatever else is going on. But that book is not free. That book is fairly expensive. So to be fair. So, and you have to have the book. All homework is out of Cutnell and Johnson. So Cutnell and Johnson, the first book I showed you, That is the official book of the class. And it's gonna cost, upwards between $120 and $150. So the book that I'll reference a lot in the class is OpenStax. That's the second book I showed you. All right, so again, very important to see. I'm gonna go back to sharing. Okay, so we're
So,
talking about,
Professor, we need to buy the book?
yes, you must have Putnam Johnson 12th edition.
Okay, thanks.
Unfortunately, I mean, there were, toward the end, one student actually figured out how to get a free PDF of Cutnell Johnson, but that was the 11th edition. So, and when you start seeing that happening, that usually is when the publishing company says, we got to make more money. And so they essentially what they generally do is they'll switch around problems, and it'll be the same book, but it'll just switch around problem, and it'll change certain things. But the reality is enough things change is you do have to buy the other book. So you do have to have that. That is the version of the book in the class, the 12th edition. So you can get it off Amazon. Whoops. You can also hang on. I did something wrong here. You can also get it in the bookstore. Sorry.
Hey, Dr. Callahan, can you show that
Yes.
book one more time?
Show it.
Yes, please.
Yes. So the book for the class. Yes, these are heavy books. Cutnell Johnson. So it's physics, 12th edition, Cutnell and Johnson. It is by David Young and Shane Stadler. Physics by Cutnell and Johnson, 12th edition.
Do we need a physical copy or a digital copy? Like, is there online homework to turn in, or do we turn it in physically?
I think the only kind of copy you can get is a physical copy of the book. There might be, I think there's different versions. Like you can get a loose leaf version. So again, you can get the hard copy. You can get a little bit cheaper. You can get the soft copy, like or sorry, you can get the paperback like I have. And some people actually have a loose leaf version, which basically they have a notebook, like a spiral or sorry, a 3-ring notebook where they have loose leaf papers in there that are the pages for Cutnell Johnson. So I've seen that as well. I've seen some students, they give a version where I think it's just his first 17 chapters. For those who are just taking Physics 1, I've seen that as well. So there's different ways that students can try to save a little bit of money. One nice thing is if you're taking Physics 1 and Physics 2, the book does not change. So in Physics 1, we do chapters 1 through 17. In Physics 2, we do literally just same book, start on chapter 18. That's 18 through chapter 31. So one way to look at it, if you're taking Physics 1 and Physics 2, you only have to buy one book, and you use it for 2 semesters. So so there won't be something else to buy for Physics 2. I mean, if that makes you feel any better. So anyway, that's the way it is. It's the textbooks are expensive, unfortunately.
Dr. Callahan, when's the
Yes.
absolute last day that we need to purchase the textbook by?
Purchase it as soon as you can, because I'm going to be giving homework starting like on Thursday. And so we're gonna cover chapter 1. Again, this is a goofy week, so I apologize for that. But yeah, I'm gonna try to cover chapter 1. We don't really get into physics till next week anyway. Chapter 1's math. But yeah, there'll be I think I only assigned about 6 or 8 problems out of for chapter 1 anyway. It's I try to ease into the class because the class is going to be a lot. I'm not going to lie to you. We're going to try to ease in, and so, but it's going to be a busy class.
Professor, is it the volume 2, 12th edition, volume 2 for the book?
Yup. If it's volumes, you'll probably want volume 1.
It's volume 1.
Yeah, volume. I think there's 2 volumes would be that. Volume 1 would be like this class, chapters 1 through 17, and volume 2 would be like 18 through 32.
Okay,
Even
volume
though I never covered 32. I think it's volume 1. I think that's an option to get the volumes, right? Volume 1 would be this class. But if you're gonna take physics 2, you'll need volume 2. I mean, I don't know if that's your intention to take physics 2, but you'll need volume 2. Or you'll just need the book. With all the all 30, there's the total number of chapters in the book is 32. Okay, let me move on here. So I'm going to go back to sharing my syllabus. Yeah, today is really an administrative day. Okay, so with that said, okay. Am I still sharing my syllabus with you?
Yeah,
Okay, good. All right, so talk about the textbook. Now, in the syllabus, some of the syllabus, the first part of the syllabus is not written by me, it's written by the school. And then as we go on later on in the syllabus, that's the part that's written by me. All right. So there's a lot of different things that you'll see from your other classes as well. Here's about, this is fairly new, paying for college. I'm going through that myself. My daughter is starting at UNT this semester, so I'm basically just like you guys, paying, trying to finance her education and stuff. So she just graduated from high school, and then my son's got 2 more years, and he'll be in college. And so I've dealt with the FAFSA form, and by the way, that form this year is very late. Normally that FAFSA stuff you're supposed to fill out in October, and it was very, very late this year. And in fact, a lot of your scholarships will also be late because a lot of the schools, like my daughter, I don't even know what's all the scholarships she's even going to have yet. And that's still being determined even through the entirety of June. They're determining that at UNT. So everything is just backed up because the FAFSA was backed up so much. So just to let you know. So I have the FAFSA, the FAFSA was her allocations from FAFSA were actually put into her account. So at least have that. But again, her scholarships are kind of like delayed. So that might be the situation for you as well. All right. Student accessibility resources, SAR, SAR. Essentially, if you are a student that has a documented disability of any kind, whether it be mental, physical, psychiatric, vision, hearing, anything that that could possibly affect your ability to perform in the class, you can go to the student accessibility resources office and be evaluated. And the office would then tell me how I have to treat you differently than other students. If I do not have the official SAR documentation, then I cannot treat any student differently than any other student. All right. And so I have some students that, for instance, they need to take their exams in the SAR office. And so if you are one of those students, then you need to tell me about that first thing. All right. So again, that would be, come to me on Monday or whatever next week. It's not retroactive. So if you feel like, okay, I took exam 1, didn't do so well on it, well, because I have this and whatever, and then you get, then you get evaluated. Well, it's not retroactive. I can't do anything about, let's say your early performance on, your performance in exam 1. I can only go from here on out. So the important thing is, if you feel if this applies to you, you need to take care of that immediately. Campus carry. So Senate Bill 11 a few years ago allows students to carry concealed handguns on campus. Now, the important thing is the word concealed, and also has to be licensed. All right, so licensed and concealed, very important. And so that is a right. I'm not really a gun person, so I'm not going to say much about it. But if you are such a person, there are a whole bunch of liabilities you're taking on. There's a number of different places where you are not allowed to go with a concealed handgun. The theater and performance halls, health services, testing centers, counseling services, physical education, early college, high school program, childcare facilities, or the police department. We had somebody open carrying a few years ago, and that person was quickly arrested by the TCC police. In fact, I believe that person was a professor, believe it or not. But anyway, you know, the TCC, we have a really good police department here. Concealed handgun, concealed carry is okay. Open carry, not okay. All right, so make sure, and then where you need to go. So anyway, that's all I'm going to say about that. Course evaluation. You have the ability to evaluate me and evaluate the class. And so I certainly, there's a link. It's available from June 18th to July 31st. So let's just say, for instance, you don't like something about the lab. You can state something like that. You know, if you're taking physics 2, maybe that can help you in physics 2, or maybe, well, or maybe you're helping the next generation of students, you know, who are coming through. But again, it's important to give your feedback. You are the, you're the customer. So again, I do everything in my power. I care very much about my students. I care very much about giving you the value of your, you know, of your dollar. So that's very important to me, that you get everything that I can possibly give you in this class. But again, if you want to say really good things about me, still evaluate. All right, so here the link is given there. Title IX. Okay, so Title IX is some things in this syllabus are a little not as easy to talk about as other things. So Title IX. Now you hear about the Civil Rights Act of 1964 that says you cannot discriminate versus against a number of different categories: gender, race, national origin, previous military service, disability, so on and so forth. So a large number of different categories that pretty much most people fit into one or more categories. And so there's a law against discriminating on those categories. Title IX, no, that's Roman numeral 9IX. Title IX is not that. It is not the Civil Rights Act of 1964. Title IX essentially is, if you could put the word, the way I say it in very simplistic terms, if you could put the word sexual or sex or gender in front of it, like those adjectives, then it probably is Title IX. Title IX is stating that it is not just against TCC policy, it's against the law to commit Title IX violations. Title IX violations, it covers a wide gamut. It is everything from making a gender-based joke, or maybe making a joke, let's say against the LGBTQ population, all the way to date rape, to stalking, all the way to sexual violence. I mean, it is very, not just TCC, but the state of Texas takes this very, very seriously. In fact, it takes it so seriously that every single person is considered, you see in quotes here, responsible employee. That includes all the professors and all the staff. What does that mean? That means that if somebody is committing a Title IX violation against you, this doesn't even necessarily have to be a student. It could be you have a crazy ex-boyfriend or ex-girlfriend who is stalking you, and they don't even go to the school. Doesn't matter if you are a student and you're being violated in this way, that becomes a Title IX violation that is important for the school to take care of, all right, and to treat. All right, and so so this is what the responsible employee clause means. It means that you can come up to me and you can have confidential conversations and information with me. You know, if you want to tell me something in private, that's fine. I'll keep that secret. If you come to me and you say, Professor O'Callahan, I want you to keep a secret for me, or I want to talk to you about something. If it's a Title IX, if it's related to Title IX, I cannot keep that secret. I am absolutely obliged to report. I'm required to report. And the report goes straight to the president of the college. Now, the state of Texas, now Title IX has been around for a long time. Been around since about 1972. It was actually put in place by Richard Nixon. So again, I'm not terribly old, but Richard Nixon was the president of the United States when I was born. All right. And so it's been a while. But Title IX really catapulted in the state of Texas in the year 2020. It was right before the pandemic, became hot. Around January is when the Title IX, when the more advanced Title IX laws in Texas came into play, and essentially requiring everybody to do this reporting. Now, our lawyer, our attorney, briefed us on this, and I was kind of wondering. I'm kind of a cynical kind of guy, and I kind of thought to myself, well, someone probably lost a lot of money on this because this state of Texas is leading in Title IX past any other state, beyond any other state. And so my question was, well, what happened? What caused this? Well, the attorney explained it. So, you have these sports programs that have a lot of money associated with them, right? These, let's say football, usually in any major university, the highest paid person is a football coach, paid higher than any kind of chancellor or president. So the football coach, like for instance, at where I got my PhD at TCU, football coach makes about over $5 million per year. The chancellor of the school makes maybe like around $1 million. And then it goes way down from there when you get to the, to the other administrative staff, and then get down to the professors. The football coach makes more money than anybody. So there's a lot of money in these programs, and you see there being gross violations in these programs. You see the Jerry Sandusky scandal that happened in Penn State. I mean, again, one of the greatest football coaches of all time, Joe Paterno, was taken down. His career was tarnished because of what was done with Jerry Sandusky and how Penn State handled the terrible stuff that was happening, or what Jerry Sandusky was doing. Then you go to the Olympic, the women's Olympic gymnastics team. You see Larry Nassar, Dr. Larry Nassar, what all the horrible things he got away with. And why? Because there's so much money in the Olympics program, so much money at Michigan State. So how does this apply to Texas? Well, the Baylor University football team had a massive scandal. There's football players that had done things to certain women that were unspeakable, and those football players are doing decades worth of time now. They're in prison. At the time, the president of the university was a guy by the name of Kenneth Starr. Now, again, I don't mean to ever speak about politics here, but to give you an idea of who Kenneth Starr was, the last president to get impeached was Trump. And then, he had a special counsel named Robert Mueller. Prior to him was Bill Clinton. His special counsel was Kenneth Starr. So Kenneth Starr wrote that Starr, and he essentially ended up becoming the chancellor and president of Baylor University. People asked him, Mr. Starr, did anybody not tell you what was going on in the football team? Did you not know? And his response was, "Oh, nobody told me. Nobody told me anything." Well, he soon stepped down from that position. He passed away, I think, a year ago now, but he stepped down quickly from that position. And so Texas's response to this was never again. Every single report of Title IX violation will go straight to the president of the college, president of the university. So, and even if I overhear somebody talking about Title IX, maybe I'm not even part of the conversation, but I hear one student talk about another student about a Title IX problem. Even if I suspect it, I have to report. That's how sensitive it is. So again, this is taken very seriously. So you can tell me, hey, you want to keep a secret for me? I'm perfectly okay. I keep secrets. That's basically a lot of my job is about keeping secrets. But if it's a Title IX violation, no, I can't keep that secret. So again, and it's all about making sure that you are protected. Nobody should be a victim of Title IX violations. Nobody. Okay. Pregnant and parenting students, Title IX also, this is really a part of the whole Title IX category, is that you do not discriminate against students who are parents or pregnant. You know, as students of young children or pregnant, you will not discriminate against that. I mean, again, to me, all these laws seem obvious, but against, I guess they're not obvious because, I mean, clearly the laws because somebody's violated them. So again, there, if you are a pregnant or parent or a parenting student of a young child, you are protected under Title IX. The care. You know, so some people get into hard times, and it could be, you know, and there's anything that where you feel like you're not safe, there's a health issue, or you know, or you don't have enough money or food. There's something called the CARES team, and they can give you temporary relief. Ever so often, I find I have a student that I grow concerned about. Student's behavior has changed all of a sudden. Maybe you know the quality of work has gone down significantly. The student has significant absences, and I will ever so often I'll go to my boss and I'll go to, you know, Professor Barrett, and I'll say, I have a concern about such and such student because, you know, and so, you know, it's a possibility that even I, as a concerned professor, and I do see everything. I do care about my students. And if I see something that I think might be troubling, I might go and try to get some CARES help. So, so again, this is something that is there for you, you know, one of your benefits. So hopefully, you know, none of you have to use it, but if it's there if you need it. Okay, that is it for what the school writes down. Now we're getting to the part of the syllabus that I write. So in here tells you what the textbook of the class is. Putnell Johnson Physics, 12th edition. Again, I showed it to you over the video. Putnell Johnson 12th edition. Publishers Wiley. The authors are Dr. David Young and Dr. Shane Stadler. There is no laboratory manual that's required. Again, I showed you all the labs in the that are in Canvas. Okay. Now, as I said, OpenStax, you know, the book that is available for download on Canvas, that's the book that I reference. And so when I do problems in class, I will do a problem number and I'll write an OS in front of it if it's from OpenStax, or I'll write a CJ in front of it if it's Putnell Johnson. So again, I will work a lot of problems out in class, and I do a lot of them out of OpenStax, because OpenStax, quite frankly, is a very, very good book. And in my opinion, and I'm a professional scientist, my opinion is it is superior to Putnell Johnson. Special materials in the class. Again, the most important thing on here is scientific calculator. And it could be any kind of scientific calculator. Anything's allowed in the class. You know, as long as it has trig functions on it, like sine, cosine, tangent, logarithm, natural logarithm, log base 10, exponential function, and of course, you know, the plus, minus, division, and multiplication. The calculator will, if your calculator does stuff like graphing and all other good stuff, it's an HB, that's fine. My calculator is a $15 Casio. You could buy at Walmart. I got my PhD with that calculator. For me, if I needed something more advanced, I go to either Microsoft Excel or I go to Mathematica or MATLAB. I mean, I go to something else where I need to make a graph. I will go to some sort of an application. But, you know, generally speaking, I got along just fine with my $15 Casio. In fact, that's the only calculator I use in Physics 1 and Physics 2. So don't go out and buy yourself an expensive calculator. $15 scientific calculator, you know, Casio, for instance, at Walmart is good enough. It's all you need. Now, regarding a ruler, protractor, graph paper, that's really not so much needed in this class. There's one lab, the vectors lab, where you will need that. But again, the lab will actually provide it for you. So as far as is what's really in special materials, really just need the scientific calculator and, the pencil, paper. Okay. Talk a little bit about what physics is. Now, again, this class is going to be algebra and trigonometry based. Now, calculus is not required, but throughout the class, I will give you the notions of calculus. I'm going to basically show you what you are missing. And you'll realize here, even as early as chapter 2, that I will tell you, calculus is really used here. This is how it's really done, but we're going to skirt around it, and we do so in a very good way. It's not like you're missing out. It's not like the quality of the course is less than what it otherwise would be, but it is incumbent upon me to tell you, what the true math is, and even though I'm not going to require you to know it or understand it. And I talk about the physical theories. Again, we talk about mechanics, heat, sound. The class is not designed for physics majors. So again, if you're some sort of bioscience major, or say chemistry, pre-vet, pre-dental, pre-vet, pre-optical, pharmaceutical, then this class is very likely for you. If you are an engineering major, no. If you are a computer science major, no. If you're a physics major, no. All right. Now, what are the math requirements? You have to have this math, and it should have been checked out by the school before you even got here. Math 13, 14 is college algebra. Math 13, 16 is trigonometry. We're going to go into trigonometry as early as chapter 2. Actually, chapter 3. Actually, no, I'm sorry. Chapter 1. Chapter 1 will do some trigonometry. So we'll see trig functions even this week. Now, 2412 is pre-calculus. Pre-calculus subsumes math 13, 14, and math 13, 16. So again, pre-calculus is math 13, 14, math 13, 16, and more. So again, if you've had pre-calculus, that's you're in good shape. The emphasis of the class is on problem solving. We're going to solve a lot of problems. I'm going to train you to think like a scientist. Again, you're wearing the same kind of scientific cloak, if you will, just different than me. My area is physics. Your area is going to be something else. And we're all, scientists, and that if you are, in a tech, you are interacting with others in a technical manner, you're a scientist. I mean, you're a veterinarian, for instance. When I was told that my dog had cancer, I brought the dog in. The dog was gagging for some reason. I'm like, well, what's wrong with my dog? And it turns out she had a giant tumor. And of course, I'm like, my initial response is, "Show me. What are you talking about?" I mean, and what did they do? Well, they showed me radiology reports. They showed me, they showed me pictures, and they had to prove to me technically that this is what's wrong with my dog. And basically, that veterinarian is a scientist. That veterinarian has a science that he or she works in and communicates to the customers. Same thing with a medical doctor. If you're a biologist or a physicist or any other kind of scientist, you're either communicating through written papers, or you're communicating with customers. But basically, all of you are training to be scientists starting in this course. So mentioned, if you have a documented disability, please see the SAR office. I cannot solve a problem if you don't tell me there's a problem. If there's any kind of problem with the class or the instructor or anything, please talk to me about it. And tell me what because otherwise I don't know. And I want to make sure that if there's something that's something with the class that is not going, that seems to be a discomfort to you, I want to know about it as soon as possible. Now, here's something that's also important here, is that I have all of my lectures on YouTube. All right. And so Physics 1 and Physics 2. Now, the YouTube is not a substitute for attendance. What's nice about these lectures, and I give the same lectures, and again, I use this tiny little whiteboard as opposed to the big whiteboards that I have in the face-to-face. But I basically work out the same problems. I do every single thing. I even tell the same jokes, if you will. I mean, every single thing is the same. So for instance, when I'm talking in class, you can't really rewind me. You know, if you're like, wait, hang on, I didn't get that. Can you go back? I mean, you can ask me that, but if you really want to spend time on it, you can go to one of my lectures. My lecture is on chapter 2 or chapter 3. And I have lectures on everything from all the way up to chapter 31 on his YouTube page. You can sit there and say, I didn't understand. Let me rewind a little bit and let me have him play that back and have him say it again. All right. And so that's important to realize. So again, if you miss class, for instance, and I've covered stuff, again, you could go to the videos and look at the videos. Now, the videos may seem a little bit longer because I make the videos one-stop shopping. You don't actually have to own the book. If you're the videos for me are for anybody in the world. I want to make physics accessible to people anywhere. I have, a lot of people who like me, let's say in the Philippines and Europe and Africa and various other places. There's people are viewing these videos all across the world. I can kind of see that. So the idea is I want to make sure that I write all the problems out. The problems that I'm going to normally you see displayed on the screen in a regular classroom, and you can kind of see the problem. I don't have to write it. Well, here I take the time to write all the problems out meticulously. And so, the videos look longer, even though they really are covering the same material. All right. So again, that is a resource for you. Now the class is going to meet physically. All right. This is a oddball week. Attendance is extremely important. The TCC has a mandatory attendance policy. You must attend the class. All right. You can miss up to, I think, 15% in attendance. After that, I'm required to drop you from the class. All right. So now there's going to be homework that's going to be assigned every single week. And I'll talk about that. The homework must be turned in on time. I am a limited resource. As far as manpower is concerned, there's just one of me. So I'm a limited resource. I can't when I grade homework, I grade it in batch. What that means basically is that when you turn in all the chapter 2 problems, I grade everybody's chapter 2 simultaneously. All right. So I sit down there and I take the time to grade everybody's chapter 2 and I grade everybody's chapter 3. I have to have everybody's stuff in front of me at once. It's not fair to me to say, okay, I have everybody's chapter 2 homework except this one person. And now, or maybe 2 people, and they just trickle their homeworks in. Now, I've already done the effort of grading all the chapter 2 homework. So when I'm on chapter 3 and I'm ready to grade everybody else's in batch, I have this John and Susie didn't turn their stuff in on time. So I have to sit there now, change context switch and grade, grade just their 2 homeworks and go through the whole process a second time. I mean, I don't want to do that. I mean, you have to turn, homework in when it is due. And same with labs. Right. And so there are exceptions if you get sick and other stuff, but the exceptions should be very rare. All right. Grading. All right. So I'm going to, I kind of look down here. I'm going to kind of look beyond the grading scale for a moment. The class is going to be 50% homework, 50% exams, 20% homework, 30% labs. So again, half the class is exams, 20% homework, and 30% lab. The number of exams in the class will be 4. They are not comprehensive. So exam 1, for instance, will be over chapters, let's say 1 through 4. Exam 2 is typically 5 through 9. Exam 3 is typically chapters 10, 11, 16, and 17. Because again, I skip into the waves first. And then exam 4 is just thermal, chapters 12 through 15. So again, it's not comprehensive. Exam 4 is given at the time of the final. There is no final exam in this class. It is just exam 4. I tell students, don't get worked up over worrying and thinking this is a final. It's not a final. Exam, the exam that you take at the time of the final is just nothing more than exam 4. It's just one of the 4 regular exams. I do not give a final. All right, and so it just so it just so happens that exam 4 is on the day of the final. All right, and so again, those are exams that they are, and I'll talk about showing your work in classes and so on and so forth, but they are exams that'll be essentially like homework problems. You'll see a problem, you'll see a space provided below the exam where you work out the problem. There's no multiple choice. And why I do that is, is that I want to give as much partial credit as possible. I want to follow your logic. I want to see you set up the problem, state the law of physics or whatever the principle is that you're going to use. Go through the algebra. Don't plug any numbers yet. Go through the algebra, and then when you solve for the unknown variable, then you plug in your numbers. You get a final answer. You put a box around your answer. Now, let's just say you do everything beautifully in a test problem. You get to the very end and, oh, you forgot to divide by 2 or something silly. You'll probably get 9 out of 10 points on that problem because everything else was done very, very well. You just goofed up at the end. However, if you mess up at the beginning of the problem, I kind of more or less say, how far did you get before you fell off the rails? And so if you really started going awry, going badly at the beginning of the problem, then I probably won't give you as much credit. All of my test questions are worth 10 points each. And so again, I try to give as much credit as possible. What I don't like about multiple choice exams is that some people get questions right by just guessing. And I don't know whether you understand the work or not. And sometimes, let's just say, for instance, you get it all beautifully done, and let's say you just messed up something at the very end. Well, you get no credit whatsoever. And I don't like that either. All right, so I try to take the extra time to spend with the exam, and I try to give you as much credit as possible. All right. So now the homeworks, there will be homework. As you can kind of see, there's about, in general, not this week, but in general, we're going to cover about 2 chapters a week. And so the homework for a given week will be due the Wednesday of the following week. And there will be usually about 2 exams per week. I'm sorry, let me back up. There will usually be 2 labs for each week. So again, homework we'll cover chapters. When I can finish a chapter, I'll assign the homework for that chapter. You'll see the homework appearing as an assignment on Canvas. All that homework is due the Wednesday of the following week. And then for the labs, there's usually about 1 to 2 labs in a week. All the lab write-ups are due the Thursday of the following week. And again, this will be written down in front of you and a little bit later in the syllabus. And again, as I said, the worst lab I'll replace that with say 100 if you do the extra credit. All right. And again, no letter grade is. Let me back up to the top here. No letter grade, ABC, etc., is given for this course on any particular material. It's only given at the very end. So I will always give extra credit on the exams. So I'll pretty much give you the extra credit for the most part. I'll tell you what they're usually short answers. The answers some famous scientist. So typically on any of my exams, you can get if you do everything perfect, you can get as much as 105. Now, the grade breakdown at the very, very end, when you add it all together, and I gave you as much opportunities as possible, but at the very end is where I get draconian. The grade breakdown is for your total grade at the very end. I have the lowest A in all of Tarrant County. My low A is 88. 88 to 100 is an A. 78 to up to 88 is a B. 68 up to 78 is a C, 58 to up to 68 is a D, less than 58 is an F. All right. Most people who take my class, the vast majority, get A's and B's. Even though physics is a difficult subject, I try to make it palatable and accessible. All right. And so most people, I mean, my rateyourprofessor.com, for instance, has really good ratings and everything. Why? Because I treat students very, very well. I care about my students. I want you to walk away from this class thinking that physics is fun, thinking that this class was a good experience. Not, oh my God, I would never take that professor again, or like, no, I don't want any of that. I want people to think that this is a class that is as accessible as my history class or my English class, that this class is not scary in any way, that this class is accessible. So I do everything in my power to try to help you. But again, there's going to be a lot of work that's going to be required on your part. And so again, you know, at the very end, I can't really, I mean, wherever your final grade falls is what I have to go with. Because, you know, you might say, oh, professor, I got an 87. And that's so close to an A. Can you make an exception? And I'm like, well, if I give you an A at 87, now the next guy down might be, well, I got an 86. Can you make an exception for me? You know, and then my grades mean nothing, and I can just get walked on down, you know, and I have to stand firm and at some point, and so that's the final grades, you know. So I'm really somebody you can approach. You know, if you think I graded you too harshly on an exam problem, talk to me. Sometimes I give points back to students. You know, sometimes I just realize, yeah, you are right. I did grade that a little too harshly, didn't I? So I might give a couple points back on that, you know. So again, I want you to feel like you can approach me, and this class is, you know, something that, you know, I want this to be a good experience. Now, there is one caveat. This is a laboratory course. So there are two types of physicists: theoretical physicists and experimental physicists. So I am a theoretical physicist. So essentially, a theoretical physicist is a person that deals with a theory, deals with the actual mathematical framework. So I'm a mathematician and physicist. The experimental physicist does the experiment. So the way science works is that oftentimes an experimental physicist will go to laboratory, see or observe a phenomena that he or she may not understand. They'll write a peer-reviewed paper in a major physics journal. Now, again, the paper must be peer-reviewed by other physicists in order to become scientific fact. That journal article goes to something like maybe Physical Review or one of the major physics journals, and then say someone like myself, a theoretical physicist, then will read that paper. Now, I may be able to then write a paper and explain what's going on. And it may very well be in a rare situation that the theory of physics actually has to be modified. That doesn't happen very often. But I might say, this is what's happening. And if I'm right, you should see this, this, and this. So maybe the same, and I'll write a peer-reviewed published paper in a major physics journal. The same experimental physicist, or maybe a different one, will read that paper. And when you perform an experiment, one of three things can happen. You can corroborate what the predictions are. You can refute them. And oftentimes what's most exciting of all is you may have a surprise. And so the idea would be that you might see something that you didn't expect. And so that physicist then writes a peer-reviewed paper, and it goes to Major Physics Journal. And then maybe myself or some other theoretical physicist can then read the paper. And that's the way science works. It basically converges. You have this pass off between experiment and theory. Sometimes experiments ahead of theory, sometimes theories ahead of experiment, but eventually there's a convergence to the truth. And it's done through analyzing data. It's done through experimental data. That's why you have this big bolded sentence. You must pass the lab to pass the class, pass the course. Why is it so important? Because lab is so important. Because this is a class, this is a course that is corroborated, that is basically supported by laboratory data. That's what makes things true. All right, so this is a laboratory plus. So you may be somebody who may get 100 on all the other exams and all the exams and do really well in the homework. You just don't feel like going to the lab. Well, I don't care what's going on in any other part of the class. If you don't pass the lab, you don't pass the class. Now, again, you're gonna be working in a lab group, so it's almost, I don't think I've ever seen anybody fail the lab. But again, I have to put that out there because you have some students that want to do things their own way. So, okay, the lab schedule, as I said, is on Canvas. Now, let me kind of go down to daily assignments. Class meets again Monday through Thursday, starting 8:30 p.m. Lectures are Monday and Wednesdays from 8:30 to 10:45. Okay, Monday and Wednesday, they'll be in NSCW 1244. That's downstairs, NSCW Science Building. Tuesdays and Thursdays, we meet for labs, starting at the same start time, 8:30 p.m. until you finish. The lab is located again in a different building, NSCE. And it's also downstairs, 1118. And that's in your schedule. The homework is assigned each lecture day for a given week. All right. So there'll be homework assigned for a week. All the homework assigned for a given week will be due the Wednesday of the following week. Whatever is assigned for a given week will be due. You'll see the due dates on Canvas. Labs are performed every Tuesday and Thursday. Each group is expected to complete a lab write-up. All labs write-ups for a given week will be due the Thursday of the following week. Now, solutions to each homework will be posted on Canvas, as I mentioned before. Now, I prefer students in the class to work problems, work everything out in pencil. Why? Is because pen doesn't erase. And so I don't want to read, be pen strike throughs and things like that. I make mistakes. I do all my stuff in pencil. So, and make the pencil dark enough that I can read it. 0.7 lead, let's say in a mechanical pencil is good enough. I mean, I get some students who write very, very light writing. I can barely even read it. Make sure that it's dark enough. That's very readable. Be aware of class announcements. Class announcements will be on Canvas. You're expected to be paying attention to class announcements. All right. Again, this is just a little final statement. Professor reserves the right to change anything at his sole discretion. I generally don't change anything. I mean, every so often we have to modify something. Maybe something took a little longer than expected or whatever. There's slight little modifications, as they say, in the sailing world, slight course corrections that have to be done. But nothing major. Regarding cell phone policy, that's important here. Do not use cell phones in class. I don't want to see people texting or playing video games in class. Please put your cell phone away. During an exam, please put your cell phone under your, or actually put your cell phones under your table, under your purse. Now, what I'm going to ask in the exam when I proctor the exams is that if you go off to let's say go to the bathroom during the exam, please put your phone kind of near me, kind of front. Go to the bathroom, come back, pick up your phone, and go back to your desk. There's not to say that anybody would cheat or anything, but we have ChatGPT these days. We have and of course there's original Phone a Friend and that stuff. I mean, I want to make sure that, not to say that anybody would do it. I just, again, it's a policy of mine that, leave your phone with me or maybe on the table next to me when you go to the bathroom and come back during the exam. But yeah, please do, respect the phone policy. Okay, that's the syllabus. Any questions at all for me? Okay. Let me bring down, stop sharing.
Teacher,
Yes.
so
Uh-huh.
like you said, the lab is during our time. We're gonna meet every day, but we have two different classes. Like the location is different for each is different like from lecture and labs.
That's
It's not
correct.
the same class.
That's correct. So let me stop sharing for a second here. So we have just one class. It's just gonna be the way the summer schedule is, it's a little different than spring and fall. Is that on Monday and Wednesday, we're always gonna meet at 8:30 PM. All right, but Monday and Wednesday, we will meet at NSCW 1244. And that's just for lecture. Okay, that's where the lectures are gonna happen. On Tuesday and Thursday, that's gonna be NSCE, different building, 1118. And that's lab. All right, so again, we're either gonna be doing lecture or we're gonna be doing lab. And so lecture meets in one location, lab meets in the other. Is that clear?
And if we have like questions, we need help from a homework and so on. We have different people to go to, or
No,
there
you just said,
is
just me.
just you. Okay.
It's just me, yeah, so you can ask me a homework question during the lab. I mean, during the lab, I'll usually get you started working on the experiment. And if you want to break away from your group for a minute, you have a question for me, let's say it's a homework question, that's fine, you can talk. I mean, everything here is the same physics class.
Okay.
It just so happens that the lab stuff is in one location and then the lecture is just a classroom.
Sure. Clear.
Okay, very good. So, any other questions?
I did have a quick question about lab.
Sure.
You said it goes, it starts at 8:30 and then goes till you're finished. Do people usually finish early or?
They'll usually take the whole time.
Okay.
What I try to do is I try to sometimes, like in physics too, sometimes the cart's before the horse, if you will, and sometimes they haven't seen in the beginning, they haven't seen the concepts yet, and I have to spend a bunch of time in the class kind of lecturing. What I try to do is I try to make sure that the theoretical material is earlier. Hopefully you've ascertained it, you've learned it before you even see the lab. That way, all I have to do is in the beginning is kind of tell you, well, here's how the lab works, but I don't have to tell you about the theory. I mean, I'm going to kind of tell you, real brief, reminder, but I don't want to waste a bunch of your time by going off and on the whiteboard and talking about the theory part of the class. I want that to already have happened such that, all right, guys, we're meeting. Here's the materials. This is what the concept's about. Let's go. And that gets you out of there as quickly as possible. Right. So yeah. So that's why it's so important that I try to keep the theory ahead of the lab.
Right. Do you have pre-labs or is it just the lab is kind of standalone?
Yeah, so that's a very good question. The lab has different portions to it. So let me share again real quick. Okay. Okay, so let me kind of go to the labs. I'm just gonna pick a lab at random here. Let's see here. Let's do conservation momentum, some lab at random. Now, remember, you're gonna be working in a group. Now, again, you may not know what this is about, but it doesn't matter. I'm just looking as an example. You notice in here that you start off with a bunch of questions. This is generally your pre-lab. The idea is, and then it'll go through and it'll tell you about the theory. Again, you've already done the theory in class with me by the time you get to this lab. So, you know, the theory should be something that should be fairly should be not known to you. And or at least familiar. Then we talk about the experimental procedure. Then you kind of go through the whole experimental procedure, what you do, all the various cases. And as you go through there's a whole data section. So you saw there's case A through E. Well, you'll take data and you'll have a place in the lab to actually write down your data. And at the very end, you'll have a post-lab section. So here's all data. The post-lab section will be a set of questions that will be relative to the actual lab that you just did. Now, if the lab is individual, which it's not, I will usually have the student do the pre-labs before, but really you can walk in not having done anything. You can work the pre-labs with your group. So all I ask of you is to know what labs are coming and kind of just read the lab, because you know what you don't want to do is not have any idea. And sometimes in the lab, you know, we have this cart these various carts that the lab tech set up, where they're kind of on the side of the room. And if you read the lab, you could say, okay, you know what cart to go to. You have like in a consequential momentum lab, you know there's going to be these carts that you're going to have to go and do. You're going to have these other kinds of sensors and other things that you know what to go to. You're not going to go to the wrong cart that's set up and drag materials off of that. So again, you know, I just want, you know, have an idea of what it is you're going to do. But everything's going to be, and again, the pre-lab and post-lab questions are going to be very, very important to your grade. So you want to make sure that you get those settled with your lab partners, and you don't just, you know, say, okay, I would check, every lab partner should check the other lab partner's work, because everybody's getting the same grade on that. So again, there are different sections. I would just say, understand what lab it is that you're doing that week, and at least read through the lab or labs before you get to class to have an idea what's going on. But no pre-work is really necessary. You're gonna be doing all of your work with your lab partners. To answer your question?
Yes, it did. Thank you.
Yes. So I want to point out, with a little bit of time remaining, there is the very first lab is the data analysis lab. Now, so what I want to do is I'm on the road. Like I said, I'm in my hotel room right now. I'll be on the road going from one state to another state tomorrow. And so I will not be able to do a lecture tomorrow. And so what I'm going to do is I'm going to ask that you look at a YouTube video for the data analysis lab. And so that's going to go through all the various mathematics. So let me kind of bring that lab up, and I'll send you a YouTube video. So again, I'm going to make an announcement on this, so that we're not going to get together again on Zoom until Thursday. And so your assignment for tomorrow will be to look over. So here's a data analysis lab. Kind of look at this briefly here. Data analysis lab is again, it goes over the mathematics that you should. I'm not going to teach this math. I mean, I'll help you with it. And I go through a lot of this in a YouTube video, but it's the lab that really goes in and tries to get you familiar with the mathematics that you should know going into college level science courses. So you'll see a number of different questions here. That's kind of like your pre-lab. And then you'll go through, and what's unusual about this is, yeah, they talk about the theory, but the author of this lab will go through all the various mathematical, I guess you say, concepts for the lab. Here you see the standard deviation. You see all these, these various concepts, and they go through all of this. And then when you go through all the various mathematical concepts, and go through here, and it's a lot, I realize. Then, and again, this is all very important: percent error versus percent difference, and Then we'll get into actually going through and answering a bunch of questions. All right, so there's a lot to this lab, and it really is a self-study lab. And so this lab will be due next Thursday. It's the only lab due next Thursday. No, the homework, the chapter 1 homework, when I'll talk about chapter 1 on Thursday, the chapter 1 homework is not going to be that much. Maybe I think about 6 problems. The lab will be the main thing you're going to want to work on. So you're not going to want to put this off until the last moment. You're going to want to make sure you get going on it. The YouTube video I'm going to show you, it's about 2 hours long. And it's going to be me going through various concepts, going through a lot of this stuff, explaining it. I'm also going to explain in that video significant figures, the difference between precision and accuracy, and a lot of the other stuff that we're going to be needing to understand next Tuesday when we talk about the measurements lab. So again, I will send that video. Again, I apologize for the weirdness of this week, but I do not intend to have lecture tomorrow. I'll put that on the announcement. So the next time we meet on Zoom will be for Thursday. And then after that, starting next week, it's face-to-face every day. All right. Now, I do want to, the time remaining, I do want to do roll. So again, if you please turn on your cameras. I mean, again, I'm going to see only a 2-dimensional view of you, but and I'm going to stop sharing here, and I'm going to hopefully what I'm going to show on here is not so give me a second here. I need to get to the section where okay. Where the roll is, so give me a moment here. All right. And I'll do roll, and I'll say a little bit more about, we're kind of running out of time here, so I'll say a little bit more about myself. I mean, read the homepage. I'll say a little bit more about myself when we maybe on Thursday. So 1 second here. Now, I think a few of you have stated a preferred name. And so I'll go by that name. If you have a name that is oh, hang on. I'm in student view. Give me a second. All right. Having issues with my computer here. If you do have a preferred name you go by, tell me. I'll do the best I can to get it right. All right. Give me a second. I'm having a little difficulty. I got locked out of my all right. I got to log back onto the system. And the system does not want to. All right, here we go. See if this works. Access denied. All right. Hang on. I don't know why it's doing this. All right. Here we go. Sorry about that. Oh. What is going on? Here we go. All right. I have a little hiccups here. Oh, no. I can't get to the, all right. All right, so I'm gonna have to just do it the hard way. School's not something wrong with the system here. Give me a second here. All right, I'll have to do it the old fashioned way. Okay, I'm gonna read down the list and I'm gonna have to put in the attendance a little bit later. All right, so as I go through, I'm gonna say your name and I'm gonna try to see if I can see you on Zoom at the same time. So first person, Nathan Copy. Are you here?
So I will
COPPI.
say that there were at least two people that did show up to school. And we didn't get the announcement. And so there was two people that showed up to the class and we were looking and we finally gave
Oh.
up and went home.
Oh, gee, okay. I'm sorry about that. I tried to send an announcement several
No,
days
you're
ago,
fine.
but yeah, I'm sorry about that. Give me a second. I gotta. All right. So
I am
I'll try
currently one of
to,
those people at the school.
I'll try to find out what may have happened to Nathan.
But I did talk to one guy. I don't know what his name was, but he was like, "Oh, are you in physics?" And I'm like, "Yeah, I don't know where everyone is." So
I'm sorry. Yeah,
no, it's not your fault. I didn't even notice that there was an announcement until after, but
yeah, and yeah, it's weird that it's the beginning of the class. So yeah, I'm sorry about that. Dorian Crutchfield. Dorian Crutchfield. So I see most everybody's here. All right. This is a very time consuming process. Yuen Ho,
Here.
Uyen. You here?
Yes, here.
Okay. Good. Did I pronounce your name correctly?
It's Win, but you can just call me UN, it's fine.
Sure. Okay. Win, like WIN, kind of pronounced that way, or
Win.
Win? Okay. All right. All right. Next person, uh, Jessica Kaiser.
here.
Okay. You go by Jessica?
I prefer Jess, but
Jess?
I call me whatever. It doesn't matter. I'll answer to anything. Even
All
hey
right.
you works.
I'll try to call you Jess then. All right. Kristen Kidd.
Here.
All right. Alana Kofkendall.
It's
Alana
Kirkendall.
Kirkendall.
Yes.
Okay. Alana is correct.
Yes.
All right. Thank you. All right. I'm in the K's here. Brian Lee. Here. And then Kathy Lee.
I'm here.
All right. Thank you. Morgan Mohan.
Here.
All right. Thank you. Gabriella Morisano.
Here.
Okay. Ruth Moaco.
Here.
Okay. Gabby Nguyen.
Here.
Sarah Plair.
Here.
Vanessa Ross.
Here.
Wolf Schweitzer. There. Leonardo Servin,
Here.
Chloe Simmons. Chloe?
Here.
Okay. Excellent. Kat Velez.
Here.
Great. You got my email, I guess. Huang Vu
Here.
and Ella White.
Here.
Excellent. All right. So sorry for the crazy way of starting the week, but like I say, I will give you the YouTube. I'll send you the link to the YouTube video for the data analysis lab. So again, that's the thing to work on tomorrow. I mean, this week is going to be 2 days of lab and 1 day of lecture anyway. So, and then Thursday we'll get back together at 8:30 and we'll do chapter 1. Does that sound good?
Excuse me, teacher,
Yes.
I have one more question regarding the homework.
Sure.
It's individual, right?
I'm sorry, what?
Is it like you have to do it in group or you have to do it individually?
This lab?
Yeah.
This lab is individual. All the labs are group labs except the very, very first one.
Mhm.
The very first one is individual.
So you have to physically print the paper and then,
Yes,
okay.
physically print the lab. All the labs have to be physically printed anyway. It's just the first lab is individual. So I should see 20 of those data analysis labs. All of the other labs, you'll get together with you'll figure out who's in your group. I'm assuming nobody knows each other yet. So when you get together physically starting on Monday, well, actually starting on Monday, we'll just do a lecture, but the first time we're together in the lab will be next Tuesday. That'll be when you figure out who's who. Then you have a group. Then you have a group in it. And that lab, that particular day, we will actually print out. The school will print the labs for you on that day. The school's very cheap. They're counting every page that gets printed and everything else, right? So they want you to print your own labs out, but they print out the first lab for you, right? And so that measurements lab will be the one on Tuesday. So again, the take-home lab is this data analysis lab. That's due next Thursday. The first physical lab that we'll do will be next Tuesday, and that'll be a group lab. You don't even know who's even in your group yet.
So next Thursday, when we get like we're gonna meet on next Thursday and we bring the paper?
Yes.
Okay.
You'll everything in class will be turned in physically. So everything. So basically next week, I will cover chapter 1 on Thursday, and it's just mathematical concepts. I'll cover it in my little whiteboard here. That'll be that homework. There's only like 6 to 8 problems altogether. That'll be due the Wednesday of next week. And then the lab, this data analysis lab will be due the Thursday of next week. Again, the only thing we're covering this week, lecture-wise, is chapter 1. And so any homework for a given week is due the Wednesday of the following week. And then any labs for a given week, which is only going to be the data analysis lab, that'll be due the Thursday of the following week. We'll
But
get in.
what I don't understand is the Thursday is the 30th and we're gonna be online. So are we gonna bring the paper?
No. Oh, sorry. Next Thursday.
Oh, next
Right.
Thursday.
Of the
Okay.
following week, right? Anything for a given week is due, any homework for a given week is due the Wednesday of the following week. Any labs for a given week is due the Thursday of the following week. So let's say next week. Next week we do chapter 2. That chapter 2 homework will be due the following week after that one. So again, every week, we'll always be pushing to the next week for turning stuff in. So this is your first week of school. Nothing is due this week for sure, right? So anything that we do this week is anything that we do is due DUE the following week, the next week. So next Thursday is the We kind of put dates on this. So today is the 28th. So the first homework assignment is due June 5th. And the first lab is due June 6th. Right? The following week. So chapter 1 homework, that'll be due the Wednesday of the following week, that will be June 5th. This lab, again, gets given this week, the following week, June 6th. Right? So again, so it's always the week after. Is that clear to everybody? Yes. Okay, good. Any other questions? right.
One question. What should we bring to class next week or lab? This class and lab.
Yeah, so make yourself a physics notebook, if you will. I mean, I see a lot of people really make nice notebooks, and then they have like they keep all their lecture notes. I mean, you basically, whatever it is, however you like to do that, you have to have a spiral notebook or a 3-ring binder that's dedicated to physics, and just basically take notes. So just what do you bring to class? Just your whatever it is, it's your notebook, your pencil, notebook with paper that you want to write on, and of course your calculator. That's all you ever have to bring with you. The lab, again, same kind of stuff. I mean, for the labs, somebody in your group will have to print out the lab for that night. So again, you guys have decided that. A lot of times the lab group is like 4. Well, in this case, it usually needs to be 4 people. That's the ideal size. Typically, people have a group chat, so they'll share each other's phone numbers, and and sometimes they meet outside of class to go work together, whatever that they do. But you can decide among yourselves, right? Is it whose turn is it now to print the lab out? So everybody will have kind of like a turn to print the lab out. Who's bringing the lab? Make sure you got that. And then a lot of times I'll have a division labor who works on what. And again, I want everybody to work a little bit on everything. And again, I'll talk more about that in the lab. I don't want somebody to be, I'm just the calculation person, or I'm just the person that does a physical experiment, or I want everybody to have a little bit of taste of everything. And so I want the lab to, and I don't want somebody just being the person that does all the questions. I mean, I want everybody to kind of, experience a little bit of everything in the lab. You're all learning about physics, and so I don't want any. Oftentimes in labs you have specializations, but here everything is we're just learning stuff. So I want everybody to kind of get a little bit of everything. Yeah, but it's like there's really just bringing the minimal stuff: paper, your notebook, whatever, pencil, and a calculator.
Okay, awesome. Thank you.
You betcha. Any other questions? You guys can sign off if you want. I got the attendance, and if you want to ask me more questions, but class is pretty much we're past time now.
Awesome. Thank you. Have a good night.
Hey, did we get hit by really bad storms yesterday?
Yeah, we did. Today and yesterday.
Yeah.
Hearing about 80-mile-an-hour winds, is that right?
Yeah, it's pretty bad. It was pretty bad last night or this morning.
I wonder my house is standing. I looked at my alarms and everything are on, so it seems like I still have a house. So okay, let's see.
Which zip code are you in?
I'm in South Lake.
South Lake.
I don't
I'm
think
north.
it happened there.
Oh, good.
Yeah,
I mean, I don't like it to happen to anybody, but yeah, I just saw that. I'm like, uh-oh.
South Lake got hit hard with hail. I was in Colleyville last night and my car's damaged to pieces. So
Oh, South Lake got hit by hail?
yeah, really bad.
Okay. How big a hail?
Baseball, golf ball to baseball size.
South Lake got hit by that too?
Yes, it was huge and a lot of it.
Okay. Okay. See how my roof is. I have a new roof, so all right. Well, thank you.
All right.
Sorry about
thank
your
you.
car.
Have a good night. Thank you.
You too. Have a good night.
Good night.
Good night.